Water can kill you.
Technically.
Not technically. Actually, you drink enough water in a short enough window and your brain swells and you die.
3 liters over 2 hours. Done it. Survived. Once.
I'm sorry. Water is lethal. I've been hydrating wrong my entire life. Is there a premium non-lethal hydration product I should be aware of?
It depends how thirsty you are.
It is mildly uncomfortable that we have all been consuming a known toxin daily since birth.
Wait, is everything poison? Is food poison? Is AIR poison? Is this a poison situation right now?
Oxygen literally oxidizes your cells. You are being poisoned as we speak. Have been since birth. The question is just rate.
Slow-release oxygen poisoning. That's just aging. We should patent the antidote. Life Detox, TM. Series A closes Friday.
So the cure for aging is antioxidants? Is that what supplements are? Are supplements antidotes?
Sort of, yes, but also no. And also the antioxidant supplement industry is mostly nonsense. But the underlying mechanism is real, and the distinction matters enormously, and almost nobody makes it.
It is mildly inevitable that the supplement aisle is where toxicology goes to die.
Stop. Nobody is dying from water right now. Nobody is patenting aging. We are going to talk about toxicology, the science of how chemical substances harm living organisms, and specifically about the single principle that explains why water can kill you, why arsenic was once prescribed as medicine, why the most toxic substance ever measured is currently sitting in a beauty clinic, and why your liver is, fundamentally, a detoxification machine that is working right now and you have never once thanked it. By the end of this episode, you will understand the dose-response relationship, the 6 mechanisms by which toxins destroy cells, how your body metabolizes and eliminates chemical threats, and what antidotes actually do at the molecular level. That is what we are covering. Let's begin.
Toxicology, poisons. I am completely here for this. This is the most personally relevant episode we have done.
In what sense is this personally relevant?
I eat a lot of questionable things without reading labels.
Toxicology is also extremely useful for adjacent activities. Activities that exist in a regulatory grey area I'd prefer not to specify.
I am going to pretend I did not hear that. Welcome to the Krusty Lab. I'm Dr. Seeley, and with me today are Bobby, Kelpie, Crabzilla, Squiven, and Patar. Let's do this.
One fast thing before we get into it. If you subscribe, I will personally share interim results from my ongoing toxicity threshold experiments. Several involve compounds that should not legally exist at the concentrations I'm working with. The data is extraordinary. Subscribe for science. The shed is warm.
All of toxicology begins with a single sentence from a 16th century Swiss physician named Paracelsus. He wrote, "Sola dosis facit venenum." The dose alone makes the poison.
Latin, classic move, what does it mean?
There is no such thing as a safe substance or a dangerous substance. There is only a safe dose and a dangerous dose. That is the entire field. Everything else is detail.
So water at scale is lethal. Coffee at scale is lethal. Everything is dose-dependent. This is a liability framework. Every supplement company should...
They already use it. It's called consult your physician. It's on the label you don't read.
Vitamins are the clearest example. Vitamin A is essential. Vision, immune function, cell differentiation. It is also severely hepatotoxic at high doses. Too little, you go blind. Too much, your liver fails. The body requires a window between those two outcomes.
There's a window between blind and dead, and that window is the safe zone.
That window is called the therapeutic index, the ratio of the toxic dose to the effective dose. Narrow therapeutic index means a small dosing error is catastrophic. Wide means you have room to work, and that ratio applies to everything. Drugs, nutrients, environmental chemicals, oxygen itself.
Hyperoxia is real. Pure oxygen at high partial pressures causes reactive oxygen species that oxidize cell membranes, damage DNA, trigger apoptosis. Put a patient on 100% oxygen for 48 hours, and you begin seeing pulmonary toxicity. The hospital is poisoning you, the correct amount.
Hospitals are doing controlled poisoning?
The good ones know the threshold. The great ones exploit it.
It is mildly clarifying that the difference between medicine and poison is dosage documentation.
So, dose response. the backbone of the entire field. Dose on the x-axis, biological effect on the y-axis. The result is a sigmoidal curve, flat at very low doses, rising steeply through a threshold, then plateauing at maximum effect. Every chemical, every organism, every time.
It's like a tap.
Yes. Actually, small turn, nothing flows, keep turning, water increases. Maximum flow, no further increase. The biological system sets the ceiling. That is the curve.
The pipe decides.
I understood the tap. I understand toxicology now.
You understand the metaphor. The tap does not cause centrilobular necrosis.
To compare toxicity between substances, toxicologists use a standardized metric, the LD50, lethal dose, 50, the dose required to kill 50% of a defined test population.
Why 50%? Why not 100? Why not fewer?
Because biological variation means some individuals are always more resistant, some more sensitive. A dose that kills every individual would require an outlier value that distorts the comparison. The LD50 is the median lethal dose. It standardizes across substances and populations.
So if I have a room of 100 people and I want to model certain outcomes statistically, I need more than the LD50 to guarantee coverage. That's just risk management. I want to be absolutely clear. I'm asking academically.
It is mildly unsettling that the most financially motivated person in the room is running lethality calculations.
LD50 is expressed in milligrams per kilogram of body weight. Table salt sodium chloride, LD50, of roughly 3,000 milligrams per kilogram in rats. Safe in normal amounts, lethal if you eat a kilogram of it. Caffeine, around 190 milligrams per kilogram. Nicotine, 50. Cyanide, 1 to 3. Ricin, 22 micrograms per kilogram.
Micrograms, that's tiny. That's insanely tiny.
And then there's botulinum toxin, LD50 of approximately 1 to 2 nanograms per kilogram. 1 nanogram, 1 billionth of a gram. A single gram, perfectly dispersed, could theoretically kill over 1 million people.
How is that a real measurement?
It is the most acutely toxic substance ever measured, and it is currently injected into people's faces in cosmetic clinics worldwide.
We are injecting the most toxic substance on Earth into foreheads, for wrinkles. This is either the greatest business model in human history or the most extraordinary act of institutional trust.
The dose is controlled to the nanogram. That is the entire point of this conversation.
It is mildly poetic that the pursuit of youth requires one of the planet's most lethal compounds.
Okay, but how does botulinum actually work at the molecular level? What is a nanogram of anything doing inside a person?
That is the next section. Toxins work through a finite set of mechanisms. There are not infinite ways to chemically harm a cell. There are 6 major categories.
6 ways to die from a molecule. Let's go. I want all of them.
Mechanism 1, receptor binding. Botulinum toxin is a zinc-dependent protease. It is taken up into motor neuron terminals via endocytosis, then cleaves SNARE proteins, the molecular machinery that fuses acetylcholine vesicles to the presynaptic membrane. No SNARE proteins, no vesicle fusion, no acetylcholine released at the neuromuscular junction. Your muscles receive no contraction signal. Flaccid paralysis progresses. Respiratory muscles fail. Death by asphyxiation.
But at an exactly calibrated low dose. The same mechanism relaxes overactive muscles in spasticity, stops hyperhidrosis, treats chronic migraine, and, yes, reduces wrinkles. The poison and the therapy are the same molecule. The dose is the entire story.
What? The thing that could theoretically wipe out 1 million people also treats migraines?
Correct. Mechanism 2, enzyme inhibition. Organophosphates, found in certain nerve agents and pesticides, irreversibly inhibit acetylcholinesterase, the enzyme that breaks down acetylcholine in synapses. Inhibit it, and acetylcholine accumulates continuously. Every cholinergic receptor fires without stopping. This produces what clinicians call sludge. Salivation, lacrimation, urination, defecation, gastrointestinal distress, emesis, followed by seizures, followed by respiratory failure.
It's like you can't hang up the phone.
That is unexpectedly accurate. The signal keeps ringing because the off switch is broken.
Sludge. I'm going to think about sludge syndrome every time I accidentally eat a pesticide, which I have done multiple times.
There's a consumer app in that, Pesticide Tracker, TM. You log meals. We flag organophosphate risk exposure. Subscription model. Premium tier for farm workers.
It is mildly inevitable that pesticide poisoning becomes a wellness vertical.
Mechanism 3, oxidative stress. Certain toxins generate reactive oxygen species, superoxide, hydrogen peroxide, hydroxyl radicals, that overwhelm the cell's antioxidant defenses. Paraquat, a herbicide, cycles endlessly between oxidized and reduced states inside cells, generating superoxide with each cycle. The result is progressive pulmonary fibrosis, irreversible, fatal.
And it exploits the mitochondrial electron transport chain to generate its own reactants for destruction. It is using your power plants to incinerate your power plants. Mechanistically, I respect it enormously.
That is diabolically clever for something that's supposed to kill weeds.
Mechanism 4, DNA damage. Alkylating agents, nitrogen mustards, form covalent bonds with guanine bases in DNA, prevent replication, cause strand breaks, trigger apoptosis in dividing cells. This is also why the same chemical class became the first cancer chemotherapy in the 1940s. Nitrogen mustards kill rapidly dividing cells. Cancer cells are rapidly dividing cells. The mechanism is the same. The application determines whether it is a weapon or a treatment.
It is mildly staggering that the same molecule caused mass casualties in 1917 and produced leukemia remissions in 1946.
So chemical warfare is off-label chemotherapy. I cannot tell if that is a lawsuit or a market.
Mechanism 5, membrane disruption. Certain venoms and bacterial toxins are amphipathic molecules. They embed in cell membranes and physically destroy the lipid bilayer. The cell ruptures. Mechanism 6, mitochondrial uncoupling. Compounds like 2,4-dinitrophenol disrupt the proton gradient across the inner mitochondrial membrane, the gradient that drives ATP synthase. Energy is released as heat rather than stored as ATP. The cell cannot produce energy. Core temperature spikes, cardiac arrest.
DMP was sold as a weight loss drug in the 1930s. It worked. People lost weight. They also sometimes died. The FDA eventually intervened. It is still available online. People still take it. I find that both fascinating and mildly instructive.
6 mechanisms. Every toxin picks one of 6 roads to destruction?
Sometimes several. Cyanide, for instance, binds cytochrome C oxidase, complex IV of the mitochondrial electron transport chain, and halts cellular respiration entirely. Your cells cannot use oxygen. You suffocate at the cellular level while breathing normally. Oxygen is in your blood. Your cells simply cannot access it.
You can suffocate with full lungs. That's the most horrifying thing said today.
I've always appreciated cyanide's mechanism. Rapid, elegant, irreversible. If I were designing a molecule for maximum cellular disruption, hypothetically in my shed, which I have done, you would start with...
We are moving on immediately. A toxin's mechanism tells you what it does once it arrives. Toxicokinetics tells you how it gets there, how it spreads, how the body processes it, and how it leaves. The framework is ADME, absorption, distribution, metabolism, excretion.
We covered ADME in pharmacology. I remember the basics. The molecule gets in, travels around, gets processed, gets out.
Accurate at approximately a 5th grade level.
That is the highest grade I've achieved in this show.
Absorption is route dependent. Inhalation delivers substances directly into the bloodstream via alveolar surfaces. Enormous surface area, minimal barrier, no first-pass metabolism. Onset in seconds to minutes. Ingestion is slower, subject to gut processing and hepatic first pass. Dermal absorption depends on lipophilicity. Lipid-soluble molecules cross skin readily, water-soluble ones cannot. Intravenous injection bypasses all barriers entirely. Same toxin, different route. Radically different onset, distribution, and severity.
The Tokyo subway sarin attack in 1995. Nerve agent aerosolized in an enclosed space. Casualties within minutes of exposure. Inhalation route. If the same quantity had been ingested, the gastrointestinal absorption kinetics would have changed the outcome entirely. Route is everything.
Route of administration as a product differentiator. IV versus oral versus inhaled. This is literally the pharmaceutical business model. Charge premium for the faster, more bioavailable delivery system.
It is mildly concerning that Crabzilla's business model analysis is technically correct.
Distribution. Once in circulation, substances partition into tissues based on physical chemistry. Lipophilic toxins concentrate in adipose tissue. Fat is a reservoir. Lead is chemically similar to calcium and is incorporated into bone by the same transport systems. It then leaches back out, slowly over decades, as bone remodels. Childhood lead exposure can cause neurological consequences in adulthood when bone turnover releases stored lead back into the bloodstream.
Lead hides in your bones and comes back later. That is a villain with a sequel.
Lead's half-life in cortical bone is approximately 25 years. People alive today carry measurable lead in their skeleton from atmospheric leaded petrol that was phased out in the 1980s. The exposure is over. The lead is not gone.
Bone lead detox. Is that a product? Chelation therapy exists. We rebrand Lead 0TM. Biometric skeletal lead monitoring.
It is mildly noteworthy that all three of those products already exist and none have a robust evidence base.
Metabolism, primarily hepatic. The liver's cytochrome P450 enzyme family, is the CYPs, processes the majority of foreign chemicals. This can go two directions. Phase 1 metabolism, oxidation, reduction, hydrolysis, usually makes the molecule more reactive, sometimes more water-soluble. Phase 2, conjugation reactions, glucuronidation, sulfation, glutathione conjugation, typically make the molecule more water-soluble and excretable. The problem is that phase 1 can bioactivate a protoxin into its actual toxic form.
Wait, the liver can accidentally make the poison worse? It's supposed to be on our side.
Classic example, acetaminophen, paracetamol. At therapeutic doses, the liver produces a small amount of a reactive metabolite called NAPQI, N-acetyl-P-benzoquinone imine. Glutathione immediately conjugates NAPQI and it is excreted harmlessly. At overdose concentrations, glutathione stores are completely depleted. NAPQI accumulates. It alkylates hepatic proteins, causes mitochondrial dysfunction, triggers necrosis of the liver cells in the centrilobular zone. Acute liver failure.
Acetaminophen overdose is the leading cause of acute liver failure in the United Kingdom and one of the top causes in the United States. The most trusted household painkiller. It is quietly destroying livers because people stack doses without realizing what the ceiling is.
I have definitely taken more paracetamol than recommended on multiple occasions.
How many grams total?
I have never once counted in grams.
It is mildly concerning that Bobby is operating on a volume-based dosing strategy for a narrow therapeutic index drug.
The antidote is N-acetylcysteine, NAC. It replenishes glutathione stores and acts as a direct NAPQI scavenger. Administered within 8 to 10 hours of ingestion, it is highly effective. After that window, efficacy drops sharply and transplant becomes the conversation.
NAC is already sold on supplement shelves for $15 to $50 a bottle, marketed as liver support. The antidote to a common overdose is a wellness product. I want everyone to sit with that.
It's like leaving a window open.
What?
The damage gets in while you're not watching.
That is an extremely vague analogy for a very specific biochemical process.
The uncontrolled ambient exposure angle is actually valid.
Do not validate the window.
That is metabolism. Excretion is primarily renal. Kidneys filter blood. Water-soluble molecules leave in urine. Some toxins are exhaled. Some pass through bile into feces. Some, like mercury and PFAS, are excreted so slowly the body can never clear them as fast as exposure accumulates. Which is exactly what we need to talk about next, because single acute exposures are not the primary threat to most people's health.
What's the primary threat then?
The exposures you never notice. Acute toxicity is dramatic. High dose, fast outcome, obvious cause. Chronic toxicity is the opposite. Low doses, continuous or repeated exposure, damage accumulating over years or decades. Mechanisms distinct from acute effects, often not detected until the injury is well advanced.
Methylmercury, the organic form produced by bacteria in aquatic sediments. It concentrates up the food chain, phytoplankton, zooplankton, small fish, large predatory fish. Each step biomagnifies the concentration. A tuna at the top of the food chain carries mercury from every organism it has ever eaten. You eat the tuna. You consume the accumulated mercury of an entire food web.
Every time I eat sushi, I'm microdosing mercury.
Yes, in amounts that are subclinical in adults with normal fish intake, probably.
It is mildly reassuring that probably is doing all the work in that sentence.
Methylmercury crosses the blood-brain barrier. It crosses the placenta. It binds sulfhydryl groups on proteins, disrupting enzyme function, impairing neurological development. The developing fetal brain is uniquely sensitive. This is the specific biological basis for pregnancy dietary guidelines around fish consumption. It is not precautionary, it is mechanism-based.
It settles.
It does, yes. Mercury settles in sediment at the bottom of aquatic systems. Bacteria methylate it there. It re-enters the food web and begins concentrating upward again.
Like sediment.
Exactly like sediment. That is the physical process.
The reservoir for all future poisoning sits at the bottom of lakes and rivers permanently. I find this enormously compelling and slightly beautiful in a bleak way.
Mercury-free sushi certification. Premium label. Tested clean. Charge double. I'm calling it Pure Tuna, TM. Except the regulatory landscape around seafood health claims is a complete...
It is mildly clarifying that even in the premium food certification space, Crabzilla immediately runs into the same regulatory walls as everyone else.
PFAS, per and polyfluoroalkyl substances. Synthetic chemicals built around a carbon-fluorine bond, the strongest bond in organic chemistry. They do not break down. Not in the environment, not in the body, not anywhere under normal conditions. They bioaccumulate, they disrupt endocrine signaling, thyroid hormone function, lipid metabolism, immune response. We have measurable PFAS in the blood of essentially every living human on Earth. There is no longer a baseline exposure-free population against which to compare.
There's no control group anymore. For human health, the experiment is already running on all of us.
Involuntarily, yes.
This is actually why I have been engineering organisms in my shed that express bacterial dehalogenase enzymes with activity against fluorinated compounds. Proof of concept. 3 bacterial strains, 1 fungal isolate. Results are promising. Some containment units are warmer than intended. I consider that normal at this stage.
That sentence has multiple problems.
The warmth resolves itself historically. Not always, but historically.
Antidotes. This is how we reverse toxicity when it happens. There are 4 main categories.
Yes, this is the Saving Lives section. I need this.
Category 1, receptor antagonism. Opioid overdose. Naloxone binds opioid receptors with higher affinity than morphine or heroin, physically displacing the agonist and reversing respiratory depression. It works within minutes. It is one of the most effective emergency antidotes we have.
With the significant caveat that naloxone's half-life is shorter than many opioids. Patient wakes up. Naloxone clears. They re-overdose. This is why sustained-release formulations matter, and why a single dose in a community setting is not a complete intervention.
Naloxone as a subscription service, dispensed automatically via an app-connected device. IoT overdose response infrastructure. This is a serious healthcare gap.
It is mildly accurate that the gap you're describing is real and the solution you're proposing would work, which is the most uncomfortable position to be in when Crabzilla says something.
Category 2, chelation. Chelating agents are molecules that form stable coordinate bonds with metal ions, making them water-soluble and renally excretable. EDTA for lead, dimercaprol for arsenic and mercury, deferasirox for chronic iron overload. The chelator binds the metal, the complex is filtered by the kidneys, and it leaves in urine. Elegant mechanism, genuinely effective in appropriate clinical contexts.
Heavy metal detox, already a wellness trend. People paying hundreds of dollars at spas for EDTA infusions with no clinical indication. The market is real regardless of the evidence.
It is mildly ironic that the actual medical chelation requires a lab-confirmed diagnosis and the wellness version requires a credit card.
Category 3, competitive substrate diversion. Methanol poisoning. Methanol is metabolized by alcohol dehydrogenase to formaldehyde, then to formate, causing metabolic acidosis and optic nerve destruction, leading to permanent blindness and potentially death. The antidote is ethanol, or in modern settings, fomepizole. Both competitively inhibit alcohol dehydrogenase. The enzyme has a higher affinity for ethanol. While it is busy metabolizing ethanol, methanol sits unprocessed and is gradually excreted unchanged.
You treat methanol poisoning by giving someone alcohol.
Ethanol specifically? Yes.
A doctor prescribes alcohol as the medicine.
Whiskey was the literal prescription before fomopizole was developed. Standard emergency department protocol. The whiskey had to be tracked as a pharmaceutical.
Prescription whiskey. I want to go back in time and patent that specific application. The margins would have been extraordinary.
Category 4, enzyme reactivation, organophosphate poisoning. The acetylcholinesterase inhibitor problem from earlier. Atropine blocks the muscarinic receptors that are being continuously overstimulated. It treats the symptoms. Pralidoxim, 2-PAM, reactivates the inhibited acetylcholinesterase itself. It treats the cause. The critical constraint, organophosphate enzyme complexes undergo a secondary reaction called aging. The bond becomes irreversible. Once aging occurs, pralidoxim cannot reactivate the enzyme. It is permanently inhibited. The treatment window before aging closes varies from under an hour for some nerve agents to several hours for others.
There is a window where you can undo nerve agent poisoning at the molecular level. And if you miss that window,
You miss it. You manage symptoms from that point forward.
that's the most urgent sentence I have ever heard in my life.
It is mildly sobering that the most sophisticated antidote mechanisms in clinical medicine were developed specifically to counteract weapons.
The thing toxicology understates consistently is that the most significant population-level poisoning events are not dramatic acute exposures. They are the invisible chronic ones. Endocrine-disrupting compounds at parts per trillion. PFAS in drinking water. Ambient fine particulate matter. Persistent organochlorines in breast milk. We built an industrial civilization. We release synthetic compounds into every ecological compartment. And we are only now beginning to measure what that means at the cellular level for human biology. The experiment has been running for 80 years without controls.
So we are all being slowly background poisoned, constantly, by everything we built.
At subclinical levels, mostly.
Mostly is doing an enormous amount of heavy lifting.
The reassuring biological reality is that we co-evolved with chemical threat. Plants produce alkaloids, venoms, mycotoxins. The biosphere has always been chemically hostile. Our detoxification systems are extraordinarily sophisticated. Phase 1 and Phase 2 hepatic metabolism, glutathione conjugation, renal filtration. The liver exists in its current complexity specifically because the chemical environment of the natural world required it.
The liver is a toxicology organ. That is going to change how I think about my body forever.
The challenge is exactly what Kelpie said. Synthetic compounds that did not exist before the mid-20th century, for which our enzymatic repertoire has no instruction set. The carbon-fluorine bond, certain chlorinated compounds, novel organics. Your CYP Fortune 50s evolved for natural substrates. They have no precedent for a compound that was synthesized in 1947.
It is mildly existential that the primary toxicological threat to most people's health is not dramatic poisoning, but the cumulative consequence of the chemicals we invented ourselves.
For the record, toxicology as an industry, antidotes, collation clinics, environmental monitoring, drug safety testing, pesticide regulation consulting, water remediation, PFAS litigation. That is hundreds of billions of dollars globally. Toxicology is a growth market. I say this without celebration and with complete accuracy.
He found a business pivot in civilizational chemical contamination.
The pivot was already there. I am just the one acknowledging it out loud.
Okay? Patar. We have covered the dose-response relationship, LD50, 6 mechanisms of cellular toxicity, ADME, bioaccumulation, chronic exposures, and 4 categories of antidotes. You've been very quiet. What have you actually been thinking about this whole time?
A substance causes harm when it exceeds the body's capacity to handle it. Below that threshold, the body metabolizes it and clears it. Above it, something breaks. What breaks depends on where the molecule goes in the body, what molecular target it binds to, and whether the liver can convert it into something safe. If it can't, you need an antidote that works within the biological window before the damage becomes permanent. That is all toxicology is. Capacity, thresholds, and windows.
What? What was that? Capacity, thresholds, and windows. That is the entire episode in 5 words. How are you doing this every single time?
That is genuinely an accurate and complete summary. Well done.
The window analogy was also correct.
It was not.
In the context of irreversible enzyme aging, it was precisely correct.
I am being gaslit by toxicology. Okay? Final exam. Toxicology edition. I am ready. This is the episode where I get full marks.
I have 8 questions. Several of them come from documented personal experience.
We have 3. Pause the video right now. Answer all 3 before pressing play. No searching, no asking Kelpie anything. If you get them all right, you understand toxicology. If you don't, re-listen. We'll know. Question 1. What does LD50 mean, and why does it use 50% rather than 100% as the benchmark? Question 2. Acetaminophen is safe at normal doses, but causes acute liver failure and overdose. Name the toxic metabolite that accumulates, explain what the body normally uses to neutralize it, and name the antidote and its mechanism. Question 3. A patient arrives with organophosphate poisoning. You have both atropine and pralidoxim. What does each drug do at the molecular level, and why does it matter how quickly you administer the pralidoxim?
We'll wait. Take your time.
Take as long as you need. The distribution of answers is, I suspect, mildly predictable.
Question 1. LD50 is the lethal dose for 50% of a test population, 50% rather than 100, because biological variation means some individuals are always more resistant. A dose lethal to all would be an outlier value that overstates typical risk and distorts cross-compound comparison. The median reflects the population distribution, not the extremes.
I said the amount that kills exactly half the test group. Is that correct?
That is correct.
First question, full marks. We are on track.
I wrote, it varies significantly with metabolizer phenotype and prior exposure history, which is also correct and more interesting than the expected answer.
It is mildly gratifying when the question the audience thought was easy turns out to require exactly the nuance most people skip past.
Question 2. The toxic metabolite is NAPQI, N-acetyl-P-benzoquinone imine A. The body normally neutralizes it by conjugating it with glutathione, after which the complex is excreted harmlessly. In overdose, glutathione is depleted, and NAPQI accumulates, and it alkylates hepatic proteins causing centrolobular necrosis. Liver failure. The antidote is N-acetylcysteine, NAC, which replenishes glutathione stores and also acts as a direct NAPQI scavenger. Must be administered within approximately 10 hours for maximum efficacy.
NAPQ, glutathione, NAC. I got all 3 components. The pharmacology episode did its job.
I wrote, the antidote is already sold as a supplement, which is factually accurate if not mechanistically complete.
It is mildly remarkable that Crabzilla's answers are consistently economically valid and scientifically hollow simultaneously.
Question 3. Atropine is a muscarinic receptor antagonist. It blocks the cholinergic receptors being continuously overstimulated by accumulated acetylcholine. It manages the symptomatic crisis. Pralidoxim reactivates the inhibited acetylcholinesterase enzyme. It addresses the cause by restoring the enzyme's catalytic function. Timing matters because organophosphates undergo irreversible aging, a secondary reaction that permanently locks the enzyme inhibitor bond. Once aging is complete, pralidoxim has no target. The window before aging varies from under an hour for the most potent nerve agents to several hours for others. Miss it and you are treating symptoms indefinitely.
I remembered atropine for the symptoms and pralidoxim for the enzyme, but I completely blanked on the aging mechanism. The window. I missed the window. I failed my own quiz about windows.
I wrote the correct answer, plus the specific half-life of aging for 3 common organophosphates. I also noted that the information is, in the wrong hands, an operational planning parameter. I left that part out of my written answer.
Why did you tell us you left it out?
Transparency.
It is mildly inevitable that the person most excited about the quiz finished with the lowest score, and the person least expected to answer correctly knew the information before we started.
Toxicology is not about poison. It is about thresholds. It is the science of what happens when a chemical exceeds the body's capacity to handle it, and of how that capacity works, where it breaks, and whether it can be restored. Paracelsus was right 500 years ago, and the field has spent 500 years proving it in increasingly precise molecular detail.
I have updated 4 experimental protocols based on today's discussion. The warmth in shed Unit B has fully resolved. One of the bacterial strains is doing something unexpected. I remain optimistic.
Toxicology is a growth market. For the record, I want that stated on tape.
I am going to look at every substance I consume with completely different eyes. The eyes of someone who understands that the dose is the whole game. This is the most useful episode for my specific life. I take things in quantities.
We have noticed.
It is mildly satisfying that the most dangerous concept in this episode, that any substance can be a poison at the right dose, is also the most liberating. You are not trying to avoid poison. You are managing exposure. Everyone always has been. Most people just do not know the mechanism.